any of you had an EKG? If you've had an EKG, you've had the leads placed there. Do you know why the leads are placed there?
Because it's what the manual says.
Fair. Why does the manual say that? So the answer is fantastic.
Welcome to the Darby Mills series, Intrepid Pioneers of the Next Economy, featuring discussions with entrepreneurs at the forefront of deploying machine intelligence and brainstorming sessions about where the technology may go at the limit.
Welcome to the Darby Mills series, Intrepid Pioneers of the Next Economy. I'm Ajay Agrawal, co-founder of Intrepid Growth Partners. Our show features Rich Sutton of the University of Alberta, who pioneered reinforcement learning. Sendhil Mullainathan of MIT, who uses machine learning to understand complex problems in human behavior. And Niamh Gavin, an applied AI scientist working on optimizing foundation models. Rich, Sendhil, and Niamh are all senior advisors at Intrepid Growth Partners. Darby Mill is all about meeting with entrepreneurs, working with machine intelligence, and exploring where their applications may go at the limit. In the last episode, we sat down with Rae Jeong, the CEO of Maneva, which is on a mission to make factories autonomous. In this episode, we'll explore some themes that came up during our conversation with Rae. Let's kick off with the first one. So the first clip is Rae talking about this active learning environment.
For us at Maneva, we're deploying our video to action AI to transform factories towards autonomy. We aren't necessarily training a one foundation model for manufacturing, but rather thinking about it a lot more towards lifelong reinforcement learning, where kind of the right mental model for it is that the agent is always continuing to learn throughout its life cycle.
I just want to step in and say, that's brilliant. The key to doing it in a continual or lifelong way is that you have to have training information continuously being generated by the process rather than relying so much on prior data sets. We need to go to a situation where the learning system, the whole factory, can get training information from its normal operation. Maybe you have an automated system that's deciding to accept or reject, sort of a quality check, and then it'll make its choices. And if you just taught it to make its choices, it wouldn't be able to learn. It wouldn't be able to learn continually. It would just learn from the training information you gave it. In order to learn continually, you have to have some deeper way. Okay, so now what is this deeper way? The deeper way could be another automated system that takes a closer look, or it could be a person. So let's assume it's a person just to begin with, to make it simple. So the automated system makes some choice. These are not good, these are good, and then a small fraction of those are checked by a person. It rejects some things, and then the person would say, oh no, that one's fine, and you inform the automated system. And then over time, the number of rejects would get very small, and the checking by the person would become a much smaller role, and it could be fully automated and fully adaptive and continually learning. Okay, well, you remember this is in a manufacturing plant, so manufacturing plants tend to be very linear and very almost deterministic because they were doing one thing over and over again, and they're trying to do it really well. And so here you can't do active learning, like active experimentation during the normal run, but you could do it and it is always done in preparatory phase, like when they first set up the plant, they try different things and they see what works best. Now, we can also call active learning like when you monitor the process and you look for rejects or look for problems to occur. And so it is action where you decide, oh, let's take a closer look at this product, how it's coming out, send it to a human analyzer or just reject it. It's a limited kind of action. And this is one reason why it isn't so widely used in manufacturing. Now, there's a general problem of you have a sequence of decisions, you have an outcome, and you can actively decide which one of those actions to do, which one of those decisions to make, like in telecommunications. I just want to note that the same structure applies in these other cases where it's less critical that you don't interrupt it or alter it, as in manufacturing is very sensitive to interruptions and alterations. And I think that's why it's hasn't been done so widely in manufacturing.
I think they're great points. And in addition, the challenge with a manufacturing plant is it's typically monitoring versus experimentation. So you don't want to have too many randomness and noise put into the system. So I think it's almost a case of, to the extent you can create a test setting in those early days or as an adjacent, and then enable the model to probe where it's most uncertain, to get that last mile of data in to augment and round out the model. But again, that's easier said than done, because the extent to which you can shrink a replicate to the side room isn't necessarily possible given the size of the manufacturing equipment. So again, what is often done in many other environments of robotics and so forth is you create a simulated environment and use that as a proxy, a digital twin, so to speak. And then you run the experimentation in that model to try and get it up to a level of accuracy that you're comfortable with, and then try and validate that in a real world setting. So there might be a case of synthetic data alongside real, just because you can't do too much experimentation in a expensive manufacturing plant where time is of the essence and they want their return on their capex, and there's real costs associated with each run.
And Rich, before we go to Sendhil, anything that you'd like to add on in reaction to Niamh?
Well, I think she's exactly right. I'm a little bit suspicious of simulations because we want to know how things will actually run. But it's true that that's always an option. I want to just point out that humans are a great package of actions and sensors. And like a person can walk around a plant and see things and tweak things in a way that is vastly superior to what you can get by trying to automate things in many cases. So it's hard to compete with a human walking around and thinking about what's happening and how to make it work better. Like a person can just reach out and shift something a little bit to one side or another, or lengthen something and put their eyes anywhere, see what's going on. And you can do all those things with sensors and with actuators, but the human is mobile and choose to look at one thing or another. And it's very much general. It's hard to compete with.
In response to your first comment about being skeptical of simulations, I would have thought that you would have been the biggest evangelist of all of simulations, because let's imagine if we were able to build a very good simulator with good physics, that it feels like that would finally unlock the power of RL, because then you could do all the exploration that is the great limitation of supervised learning, and that that a superb simulator, to the extent that one is ultimately developed with good physics and surface physics as well, that would enable so much of what is the potential of RL would be liberated with a good simulator.
I kind of just think that's not possible. That the world is really complex, much more complex than our minds, and much more complex than any simulator you might build. And in manufacturing, you often care about those things that aren't in physics simulators, like how gooey the chocolate is, and does it stick, or does it drip, or does weird things happen. And it's not just about chocolate. I spent a large part of my early life working on light bulb factories. You're trying to coat fluorescent tubes with something that will glow, and how long does it take to drip down, and does it form smudges or something? All these things are really, really hard to simulate.
I see why you think that that's the best use case for RL, but arguably, when the world is already inside a box, it's also, we have many other tools that would be competitive with RL at that point. So in some sense, yes, it's an ideal use case it's also an ideal use case for many other things. I mean, just there's straightforward optimization you could just start doing because you have the thing in a box. And now we're really just saying, is RL better at solving something that so whereas I think, if I'm not paraphrasing too much, Rich, I would have thought the way I understood your answer, which is also the way I understand it, when the world is unknown, that's where there's very much a strong argument for RL, where you need to build your own provisional world model and continue to evolve it. And that continual evolution of this internal world model, what that mean? There doesn't need to be one, but a proxy world model. But can I go back? I found this one to be, it was the first one we did, so I was like, oh my God, is this are they all going to be this hard? I found this one the hardest one to really kind of. Maneva was just very hard for me to wrap my head around. And let me tell you my confusion. And maybe Rich, you're ideally suited to this, but Niamh or Ajay, you may have thoughts on this. They kept saying reinforcement learning, but I really just didn't understand. Like, is there RL here, or is this just super? I mean, they're like, oh, we'll keep getting more data. I said, okay, more data. That's supervised learning. I understood what they were doing. It just felt like there was a mismatch between the words of RL and the vision. Just like, oh, and then eventually. And like the specific example, was it as confusing as to you all? If it wasn't, then please explain it to me. I think I tried, but I think at the end I was like, I still don't quite understand. What I mean is, I think I understand what to do on a day-to-day basis. I just didn't understand what's the RL bit here.
I think we all see what you're saying. It's not obvious that you want to do experimentation, just like Niamh was talking about, because it introduces randomness and variation, which we normally don't like in manufacturing. Often I will extend the phrase RL, reinforcement learning, to include extended predictions, temporally extended predictions. So it's like RL is reinforcement learning, does deal very much with temporal things like value functions, and value functions are not actually control, they are prediction, temporal prediction. So we extend to that. I think it becomes pertinent, or almost obviously pertinent. Yeah, maybe you could try to do everything in a supervised way, even the inspection, but you're trying to predict delayed outcomes that may be delayed. I'm sure I more than most people see reinforcement learning everywhere, and the potential for it everywhere.
Okay, as long as, because I appreciate calling something. It's a nice phrase, a little bit of overextension. I'm not nitpicky, but I wanted to make sure there wasn't something I meant but I also felt like, Rich, you were sort of saying in manufacturing it's hard, and I guess I'm less sure that it's hard. And let me push back. There's just so much stuff that actually happens in a physical plant. You know what I mean? Like, there's power outages. Somebody sets the speed of the thing every morning. Sometimes they set it differently this way, that way. The ambient temperature has changed in the actual factory. There's just so much variation that naturally happens anyway. That if we actually just sat down and said, look, we're not building, these guys are making chocolate. They're not building silicon chips. Can't we just realize these production processes have tons of variation, kind of recognize that and say, what's a little bit more? Raise the temperature on the thermometer, lower the temperature on the thermometer. Anyway, there's variation happening. So let's just add a thermometer into the pipeline of like what the temperature is all in each step of the pipeline. Recognize that the temperature is wildly varying because that's not the thermometer that's being optimized against a machine. There's external temperature. Let's do the same with humidity. What if we metriced it up to capture all of this important variation that's anyway happening? And then let's do RL around that in some way.
No, that's what I actually understood it to be. And it's a strange paradox, as you're saying, in terms of it's a controlled environment, but the upside of that is there are few variables that is within our ability to manipulate. And so I thought that it was around increasing sensitivity beyond the human hunches that Rich kind of alluded to. Increase your metrics and sensors and data around it. And then you can simulate kind of around the variables and the impact you think you can have on that. Create kind of a policy or a reinforcement loop. Well, or it could just be a tree diagram, as you say, of if this, then that. And then see if you can operate or translate that to the real world environment in the machinery of, okay, when the temperature hits this rate, you need to turn on the air conditioning or things like that. And that's kind of the action off the back of it. And then you have that reinforcement loop of, did that actually have a causal effect that you intended? But the challenge I found in manufacturing as a whole is a lot of these systems are done by kind of big archaic companies, which don't have natural data feeds off because they want the kind of the captive mechanism of that proprietary tool, but also they're not as easy to fine tune in real time. But I would say we also should put in the asterisks of he is from DeepMind, so therefore everything is deep RL. But that was how I kind of interpreted it.
I was taking the same attitude as Niamh, that this is what we were talking about. Using the natural variation and using a limited amount of variation introduced by the machine to see the consequences.
I think, Sendhil, one of the things, at least in my conception of all this, of why it lent itself to this, is that the reward can be quite precisely defined in terms of the output from the manufacturing process. And so you've got all this variability upstream. And so, for example, I think it was you, Sendhil, in an example that you gave in the discussion, talked about variation in the quality of the cocoa beans. And then Niamh brought in the variation in the vibration of the machine, and like picking up all kinds of variation in IoT sensors like throughout the thing. And then because we can measure whatever are the quality attributes that we're trying to measure on the outside. And then Rich later went on and said, look, you don't even have to stop at just measuring the output of on the outside of the factory. You can go further down the pipe and measure revenues and prices and so on. So let's press on. Chris, if you could play the just the clip from the next bit. It's a short one, but I think it'll be helpful here on exploration.
In the process of the algorithm being deployed, let's just use chocolates. Of the ones that are maybe a random sample, like Rich was saying, maybe of the ones that are flagged, there's some human feedback, so we're getting more labels coming over time. So in that scenario, what's happening is there's a steady flow of additional labels coming in that a good supervised learner is getting better and better at. There's a second possibility, which is that there's something, the action part of the reinforcement learning is actually doing more work. Maybe there's a bandit part, maybe there's something else, where in the algorithm, there's actually choices being made where maybe it flags certain things selectively in order to collect more information. Maybe the flagging itself leads to something. And there, the feedback from the human is dependent on some of the action, so that the labels coming back from the system depends on the action chosen. So in one case, it is continuous data enrichment, and the algorithm is going to get better because more data is flowing in. In the other, there is actions being taken that in turn affects the kind of data that is being produced, and that data then affects. Help me walk through which of these two we're in, because of that, or a third one, as I said, because that will help me understand at the bottom what is happening. I think it'll help me understand what the labels are and how the learning is happening.
The area that you've mentioned around reinforcement learning, but also have a meaningful impact around what we're going to see in the manufacturing industry, is actually around exploration, where when the action influences the data distribution. That's what we call exploration. Right now, our AI are taking care of a very specific task where we say, hey, please do this task, and it just does that. I think this is going to take us quite far, but I don't think this is going to open up the next Toyota manufacturing, the next Kaizen, next lean manufacturing, right? I believe the next major shift towards efficiency in manufacturing will be driven by AI, but it wouldn't be just getting there through automation. I think we're going to need to see AI systems starting to take actions that are exploratory and starting to take actions where they can run the experiments on their own to get us into the next stage of what's possible.
I would have thought the real breakthrough here to be had is to take the hard problem and to crack it and make it manageable. Like, I totally accept that exploration is hard in manufacturing. Totally accept that. But I think what I was trying to push them on is like, okay, but can we get the thin end of the wedge into there to find subversions that are doable, do more of that, and then try to build up more and more from that, if that makes sense? And I just couldn't tell if that's what they were doing.
Just want to say, maybe to add to that, is that it was very clear in one of the later clips that Rae really wants to do this. He wants to actually change the process based on learning. There's enormous room for changing the process, beyond like little tweaks, do this a little faster, that a little faster, do whatever, different temperature. You could say, well, no, this machine needs to come out and be replaced with a different machine. Those kind of decisions, those are the things that would really change the game.
And I think it's exactly that makes me like a dog with a bone on this. If that's his vision, and I think it's the right vision, then to me, it seems like the business question is, how do we take the minimal steps now that are, like, as an example, all the temperature stuff, fair, it's small peanuts. But how do you build the case for the big thing without showing that there's a lot of ROI on the small things? And like one thing I took away, especially this second conversation is really helping me, is that I would have said to myself, if that's my big vision, my short run goal is to show the value of RL, even on tiny things. My medium run goal is actually to say factories need to make themselves more RLable. Like by asking the question, what is the dollars you can spend into the process to make it more RLable? Like if we believe in the RL approach, we should say, great, what are the small to medium to bigger changes that I'm going to make? What's my pathway? Because equipment gets replaced at a certain rate. The next time you have to replace this equipment, here's an extra X dollars that you can spend. That extra X dollars makes you more RLable. Like I would have had a strategy pathway, which was, show value, figure out a strategy to make the machine more. It's like putting on my economist hat. What all this should say is there is a return to activity X. The activity X is the capacity to do RL.
Exactly. I know. I think you're totally right in terms of with all these things, it's often if you have a tech person starting, they start with a model and then figure out the business case later, where often you need to kind of start with what is the business model for this. And I think you're absolutely right, Sendhil. And I don't believe it a disconnect. It's just an articulation around how do you take this and make more informed decision making as a whole across the factory, be it within the machine and the actions it takes, be it within the people operating the plant, or be it those operating the budget and the P&L and making those replacement decisions. And over time, the more data you gather, the more informed you are about what does and doesn't work. And if I pull this lever here, this is how much I generate and where's the greatest leverage. Then you can start to do optimization of the factory as a whole. And I thought where they were going to is currently, if you're dependent on humans and that human touch and feel, you can't operate 24/7. Whereas if you start to kind of automate and gather those instincts and codify them and integrate it into the model and fine tune the machine to keep it within that ambient range of optimization, then you can say, okay, when they clock off at night, we can just have two people on who just supervise a machine and polish the servers that enable that 24/7 operation that we didn't have prior. And that's where your ROI really kicks in because you don't have that downtime of the machinery too. And then if you start to put in predictive maintenance, you can go in and find the loose cog or whatever before the machine breaks, because as you know, with any downtime is huge impact on the bottom line. So I think it's more their articulation of what does this mean for my P&L and balance sheet as a whole, and then you need to come back into the competitive dynamics of, okay, if I can create artisan chocolate at an industrial level, then I've created a competitive position in the market. But to the extent to which you need RL versus supervised, within that is still TBC. But I'm one where it's horses for courses, and you need a mix of things in order to get the right outcome.
Prediction tends to come before control. It's just easier to do. Prediction means I'm going to monitor things and warn you of things that are happening. Maybe I'm doing the inspections and the rejection and things like that. This is the lower falling fruit, and prediction tends to come before control. To give the machine direct control of the machine, of the manufacturing process, all your managers are going to revolt or hesitate. They're very hesitate to give control to a machine of their factory. It's just so scary for them, and it's natural. I think it's natural and appropriate that prediction should go before control, and that the initial demonstrations will be prediction. And prediction, in my mind, is not so far from reinforcement learning if it's a long-term prediction, and if it's done from the natural feedback that occurs in the factory rather than from human labelers. It's not so far from reinforcement learning. I don't know. I thought of one more example during the discussion was, like we've seen this variations on the chocolate. So with maybe the temperature, the humidity, and the environment. And so if you did that, if you just instrumented the system and learn those predictions and learn the long-term consequences of those variations in humidity, you might decide to take an action, which is don't allow the humidity to change that much, right? Do some air conditioning and control the temperature. Or you may decide the reverse, that it doesn't affect that very much, so you don't have to invest in greater environmental controls. So that's kind of just decision that's made about a manufacturing plant. Put this machine in or take that machine out, or control the temperature more. These are decisions that cannot be. We can't have an automatic system that tries putting in the environmental condition, in the air conditioning, and then takes it out. No, it's got to be based on a solid prediction about the outcomes of that. A decision in a manufacturing plant would be like, maybe we should produce this in a different way. Maybe we should use a different recipe for this chocolate. They're big decisions, sort of. So when we take it to the limit? Age's questions, one of his common perennial questions, what if we take this to the limit? What will it look like? Because there will always be things that can be measured, and we can instrument, and we can track, and we can predict, and we can anticipate costs and failures and other delayed outcomes. That's true. But do we really want to instrument everything? Instrumenting is costly. To put all those sensors in and to put actuators in. What is it going to look like in the limit? Because in the limit, it's still true that manufacturing processes are mostly feed forward. They just flow. We control the conditions, and then we go forward deterministically. And we manufacturers love that. So I think in the limit, there's still going to be a person, because the person is this wonderful package of mobile sensors and actuators. And what will the experimentation be? The experimentation will be like, put a sandbag on that machine and change the vibration. Okay? Do we want to make a robot to go there and put a sandbag or not? No, we want the person to wake up and talk to his factory. Say, okay, Morning Factory, I'm doing the rounds, and the factory says, well, why don't you take a look at machine number 4 and just see if you see anything, and while you're there, just kind of nudge it in this way, and I'll watch and see if anything happens according to my measures. And he'll be talking to it, and we'll be doing these things, or maybe it'll say, okay, today I'd like to do an experiment. Let's try running that at 10 degrees higher. I don't have to instrument it so that it can automatically change the temperature. Maybe I do, but there'll be cases where it's just easier to have the person walk over there and turn it. And then the machine watches. The machine is really good at chasing all the detail and looking for causal links. It's not very good at reaching out and changing something. It's not very good at looking, in detail in a new place, whereas the person can just, turn around and look at it, or you can walk in and take a camera and put a camera in there just for today. To put that camera in, you need a person.
And I think you've hit the nail on the head here, Rich, in terms of one of the consequences of the democratization of computed AI is people are using it to solve everything. Sometimes there aren't problems to solve, and there's no substitute for just common sense. So they need to strike the balance of like noise to signal in terms of saying, okay, we've done our evaluation. These are all the variables we've identified. Now we're going to systematically go through them and see which has the greatest effect on the thing that matters to the plant operator. And then have a side-by-side of, is it, to Sendhil's point, is the ROI greater if the machine does this versus we just alert a human to do it? And again, it's just a classic case of if this, then that, and see which is the levers worth pulling, and then trying to narrow that down to kind of your 3 to 5 recommendations per year, as opposed to here's 100 alerts going off, which just aggravates and irritates everyone. It's full of false positives, false negatives, and now I'm going to just turn off everything and go back to the way things were before. So I think you hit the crux of the issue there.
By the way, alert management is something that I think would be really good for reinforcement learning, because you generate alerts and you discard them, and it's not interrupting the process. And although you may choose to as a result of the alerts. I also think about the kind of manufacturing we're talking about we're talking about in the limit. We're not talking about, one sense of in the limit is something like Tesla's gigafactories, where everything is automated, okay? And the real choices were the design of that factory. How will the machines work, and what will each one do, and even like how many bolts to use in this in this part or that part. These are not things that a machine can like try on the fly. There's things that can be designed. Now, so I think that in Tesla that maybe will stay that way, but things like the chocolate factory are smaller choices, and they're medium-sized manufacturing, and it's going to be a mix of automation always.
If you've got a white sheet of paper, you can use the AI to design the optimal one up front, whereas if you've got existing plants and manufacturing, it's more incremental in terms of how do I optimize what I have today and then inform the next decision when it comes to the next purchasing moment.
And Sendhil, Niamh has just laid this out very nicely as, in some sense, a dichotomy between the new factory and adjustments or retrofits to an existing factory. When you raised your point about making a factory more RLable, did you have something in mind that was different than those two extremes?
No, I think it's very nice. I think the part that I had in mind was more, it's related to your the example we talked about electric power changing factories. The thing I like about that story is it illustrates how big the change has to be and how we can't get stuck in the incrementalism of it all. And I think that the temptation is that pragmatism can hinder actually realizing what needs to get done. It's a sort of too local of a pragmatism. And I think if we've been having this conversation about electric power, it would be like, wow, we can't really change it. We got to be realistic. It's like, well, no, we have to change the entire factory. But I think the thing I was sort of alluding to with the RLableness is also an element of how do you create the steps between the present and a big radical change? And I think that is the bit where it feels like creativity is needed, because to get big radical change, you could say, guys, let's just try this total other way. But we're not even quite sure what the other way is. All the examples you give, Rich, are exactly right. Like a bunch of things don't need to be done by, made automatically. It's done by a person, maybe even better done by a person. But a bunch of things probably would be. How do we decide what those look like? Where do we see what things are? And I think part of trying to create those local changes is that. And I think wanting to push the envelope at the level. I'll give an example. I feel like I know medicine very well. So I'll give you an example of a thing we're working on. Any of you had an EKG? Actually, most of you probably had an EKG. If you've had an EKG, you've had the leads placed there. Do you know why the leads are placed there?
Because it's what the manual says.
Fair. Why does the manual say that? So the answer is fantastic. It's where the inventor of the EKG 120 something years ago, Eindhoven, I think, placed them. That's it. There's not some elaborate procedure where we experimented with other things. Case in point, you've never had a lead on the back of your chest. The heart is also back there. It's not in the front of your chest. It's sitting in the center of your chest. Why no lead in the back? I don't know. Eindhoven didn't give it a shot. We haven't tried it. So if you said like simple RLable, it would be like, well, right now that process isn't RLable. I don't measure where the leads are. There's going to be variation because no person is perfect. But I haven't set up a system to even ask the question, what if we had done it differently? Now you could say, oh, it's going to be very expensive. Is it really? Does the nurse really care? The nurse doesn't care. Now there is a kind of expensiveness, which is there's no backward compatibility if you put it in the back of the house. So there's complexity. So that example illustrates that we need stuff in the middle, and we need to be doing stuff in that space. And I just would be wary of thinking that it's all left or right. I think that's mainly what I was trying to get at.
So let's jump to the last clip of this segment, because I think this is relatable, which is where we ended off in the last session on this idea of factory-wide temporal credit assignment, because I think that's related here in the sense of, do we allow the kind of flexibility that Sendhil's speaking about? And if so, we have to design it in a way that we can do temporal credit assignment to all these different options.
I keep thinking of Ajay's goal to take it to the limit. And take it to the limit in a factory. We would like to be sensitive to the ultimate outputs of that factory. And whether they're high quality chocolate or income produced, we wanted to create that loop that Sendhil is talking about. And there are tight loops and longer loops. The longer loops would be like, you ship the chocolate out and you look at your sales. We're looking for places of getting feedback that can be automated. Factory-wide credit assignment. Many changes were made. There are many steps in that process. How do you assign credit to the various stages? How do you figure out which one was responsible? Was the cause or why for the failure or the unexpected good result? It's just like in a chess game. In a chess game, you make a whole sequence of moves and then you win. And how do you assign credit for winning to all of the individual moves? Some of the moves might have been good, some of them might have been bad. Sometimes we call it temporal credit assignment. This is the goal, the factory that can do thorough factory-wide temporal credit assignment.
So this was the discussion. Maybe we can link this where we're going today and Sendhil's point about making factories more RLable. Empirical economists spend enormous amounts, fractions of time when they're trying to understand the relationship between things of establishing causality. And this temporal credit assignment is like the computer science's language for referring to causality. When you said, how do you make a factory more RLable? My interpretation of your comments was, how do you instrument things in order to learn all these causal relationships? Like, what does the ultimately RLable factory look like?
I think to me, there is definitely an element of causal attribution. But I think there's a second element, which I think economists don't really think about, which is setting yourself up to explore the space of choices more richly. Like if I think of what these technologies are giving us, they are raising the returns to exploration. And so if the returns to exploration have gone up, we should make those changes that allow more exploration. I think both Niamh and Rich, I think have really changed my mind in this conversation, which is I think the where it ends up, I think, is being able to ask the question and answer the question, what are the parts of exploration that are automatically done through some controller and computer? And what are the spaces, parts of the exploration space that are done in tandem with the person or done by the person? To me, that seems like the question we need to better understand what does that boundary look like at the limit? We can speculate. There's going to be a lot of high frequency choices where you feel you can learn a lot, that we ought to just be doing a ton of that. And so to me, what I think I've taken away from this conversation is the part of what we have to understand in the limit is to know what that boundary looks like and what things sit on this side and what things sit on that side. And I think that's kind of fascinating.
And the only thing I'd add to that for each is who the end customer is for each of those decisions. So exactly as Rich was saying, for some of it, it's the manufacturing plant operator, but at the end of the day, it's also the end customer outside. So linking it back to how sales dipped as a consequence and because of the taste changed or things like that. But as with anything, it's knowing the objective of your metric and who's the end user that it's being measured for.
And so, Sendhil, when you made your comment about this technology increases the returns to exploration, okay, then what that means is if you get some technology shock that increases the returns to exploration, that means you want to invest more in exploration because you get a higher return from it. And so that means, and now I understand what you were saying by say there's two parts of this. One is, yes, there's the temporal credit assignment, that's causality. But even before you get to causality, you want to increase the explorability of the system. So that's how you are increasing your investment, given the increasing returns to explorability. So what does it mean to make a factory more explorable? It means that you are designing it in a way that you're enabling more variation, if you think that you're allowing things to vary more and that those things are combinatorial, that you are exploding the space, because, if you increase the variability of like 50 things, then all the different permutations of the combinations become very high. And then if you can track the causality in terms of, if all these different permutations lead to different outcomes, that the factory of the future and the limit is one that has these properties. Is that, Sendhil, is that a reasonable? Okay.
Perfect.
A couple thoughts. One is there are physical actions and there are informational actions. And there's a lot of room in informational actions. So, for example, the processing of alarms, which alarms are brought to the attention of which people, those are informational, control of the information flow. And another informational action that I'm kind of excited about after everything you guys have said is where you place the sensors. This is the whole, just like where you place the sensor on the EKG. Do you put one on the back? And so the answer for the EKG is, yeah, you should be able to try that and see if it's useful for anything. And then, try it somewhere else. Try it on your toe or something. I don't know. And do that. So in order to do that experimentation, you're going to require a person or a robot to do it in tandem. And I think that would be a great thing, like you've got these cameras, they're kind of a deal to install permanently because you have to get power to them. But if you want to put a camera up in a place, just for a couple of days, it's really cheap, just for a person to walk in there, duct tape it to something or clip it on and have them look and the machine can see, oh, is that correlated with anything? Is that enabling to predict anything? Do I see something? And that's informational. You're getting different information in the machine, and that will a key part of getting to the stage where something physical might do, like to permanently install the camera there, or to install something else to measure something which you're seeing hints of in the visual stream. Informational actions, I want you to think of them as actions, as explorations. What if I measured that? What if I measured something else? And there's a huge combinatorial space of what things you can measure. So you want to be able to make changes. You want to instrument a lot of things, and you want to be able to be very flexible in your ability to change what you can instrument, both what you can control, but also very much what you can measure.
And when we take this to the limit, and if we keep pulling on Sendhil's thread of making something more RLable, even Rich, when you described putting a camera in a place temporarily, and then the implication was, well, if I'm taking a video signal from that spot, and I don't find anything that's that correlated with anything I care about, then I can just move the camera. But then later I change something. And so I don't know that video signal might now be valuable. It wasn't before, but it might now. My point here is that as we make things, and given the combinatorial nature of things, it sounds like to make something more RLable, and in the limit, you could imagine almost you want sensors and actuators everywhere. Because even though you didn't, like a sensor wasn't that useful at one point, because you changed something, that sensor might be valuable later. And so maybe you want to economize in the short term and not censor up everything, but it feels like in the longer term, the ultimately RLable system is one that is fully sensed up and with actuators on everything.
I would like that, but it seems like that can't be the answer, just because these things do cost money. It costs money to install and maintain, and it's combinatorial. The space is very, very large. You can't really do everything. I'm starting to appreciate the beauty of a selective instrumentation. Of this is our action. Our action is what are we gonna? What's sort of a meta action and a meta sense.
I'm wondering, Rich, it's actually when we take that practical perspective, which I like. I'm wondering if there's, and this may be somewhere in the literature, but I'm trying to figure out if I even know it. You could almost ask a different question of the algorithm that you have in place. which is, what is its best guess of where a measurement might have value?
I was imagining the designer of the factory, the one who made the machines. And he was undoubtedly thinking, like the temperature here is important, or that person has a very good sense of what might be really interesting to measure. And the same would be true for lots of the people involved, the designers involved. And I think we want to pass that. The designers are no good at processing, 2 years worth of data from that machine, but they would be good at saying, oh, maybe you want to measure this, maybe you want to measure that. That might be interesting.
And just to kind of touch back on Sendhil's point as to where have we seen this before, I was thinking about drug discovery in terms of we were the victims of our success around increasing the experimentation and reducing the cost of sequencing. And we went from just first genome sequencing to then kind of protein to then whole cell to kind of tissue. And suddenly there was this huge explosion of data where we had so much data coming off the machines, we ran out of storage and there wasn't enough time to process it. And then we were trying to discern, well, what is the signal versus the noise, and what is the causal impact? And there we were overwhelmed by too much information all at once everywhere. I think there was a famous Jeff Bezos memo, quarterly kind of financial memo, exactly on this point of, if we maintain cash flow, that gives us optionality to do experiments. And you should know that the real variation or game changers come from the 10% that succeed, but you need to have 90% fail in order to get that 10% upside. But the cost of that 90% is far outweighed by that one. It's almost like a VC portfolio, right? Of we're gonna spread bet and know that the majority will fail, but that will all be offset by the one.
I'm so glad you said this, Niamh, because I think that the incentive statement is too broad brush. Let me tell you some some experiences we've had in this healthcare startup space. It's not about how much dollars are gained relative to the cost. It's to whom do those dollars accrue in the org, and what is there. And the reason I'm saying that, I think that in the back of my mind is why I was pushing the Maneva to try to build the case that there's huge value in making something RLable. The reason is, then it's no longer trying to sell to the factory manager. That's a CEO level sale. Because the CEO, you say, this is a change in the vision of your company. Here's how many dollars are here. It's a very different sale if you're always selling to the owner of the factory or even the person in charge of operations at the manufacturing plant than if you're selling to the CEO. Now, you have to have enough zeros to try and make the pitch to the CEO, but you also then have a different kind of body and evidence. And so it seems to me the even to your point about attribution as well, Rich, many of the benefits aren't accruing to the head of the manufacturing of the factory. Quality goes up. I don't know. That has nothing to do with me. I'm just I'm the guy trying to keep costs down. And so I think trying to keep all of that is one reason I was trying to push to try and say, look, let's make the CEO level sale.
Where I really like that we've gone here is when we push this conversation of thinking about this at the limit and the RLableness of a factory, is it's forced us into a conversation that links the technology to economics. And in other words, it feels like this conversation can happen without considering both simultaneously.
There is an eternal trade-off between exploration, exploitation. And so they have to be balanced. The whole point of the main message of reinforcement learning is that you can't do either one to the exclusion of the others. You have to balance them. But the precise balance has to be chosen sensitive to the context of your situation. And we're talking about how that can be done. I don't know if it's more reinforcement learning like to be highly exploratory or not. And maybe it's just reinforcement learning says you have to pick that balance in a sensitive way.
No, it tees it up nicely in terms of everything's a balance, everything in moderation, right? You can't get away from that old adage. But similarly with exploration, exploitation, or risk reward, I feel it's also between machine versus human. So what are we great at that we're able to discern and do better that takes too much computational effort? And where is the nuance of the detail or continuous monitoring that's required that we can't just do? And that's how you divide and conquer in a traditional division of labor. And so that's what I think is an interesting choice as well.
I think the thing that jumped out at me a little bit, well, first of all, it's really good to have this discussion at length after Maneva. I mean, I feel like I understand them so much better now. I understand the whole thing much better now. This is just fantastic. But I think the other thing is, I think you've mentioned this, Ajay, is like, what happens at the limit? Maybe it's time to revisit that metaphor, because I think if you look at this conversation, the phrase "at the limit" suggests we reach some static point. Whereas if anything, what all of this is telling us is what happens, quote, at the limit. Well, that's when the actual change really begins.
Paradigm shifts, right? It's kind of like you get to the top of the S curve and then you need to jump and make the leap to the next. Yeah.
Exactly. And even more extremely, what is happening at the logical consequence of these technologies is a possibly permanent, but certainly for quite time enduring period of massive rapid change, because now we have increased. So it's almost like the limit is not the limit is the beginning of the story. And so it was interesting to me that the metaphor is starting to break down in a good way, I think, like all good metaphors.
And Sendhil, can you, just as a final comment, when you made the comment earlier about increasing returns to exploration, and Rich just said that, half a century of research in reinforcement learning, and he says, look, one of the key themes is you need both. You need a balance between exploration and exploitation. But when you say increasing returns to exploration, that implies that the sort of the balance, the optimal balance is shifting, and that there is increasing returns to turning the dial more towards exploration.
Yeah, great. I like that. I'm glad you, because I was noodling on what Rich was saying. I think when we have a fixed technology, we balance the two. What is the technological change in this case? Is that we had a human process for understanding the consequences of our explorations. And as humans, we're not good at squeezing all the juice out of the explorations we are already doing. Frankly, we're very bad at it. We have this paper on seaweed farmers of all things, which at some point we can talk about. And in that paper, what we basically show is seaweed farmers were inadvertently exploring quite a bit. These are poor farmers. We're exploring on things like what size pods they use when they plant. But as humans, we're not good at seeing the consequences of all that random variation. It turns out there's huge returns to changing pod size that they never noticed. Like, these are poor farmers that could have had a lot more income than they had. And since as humans we weren't good at that, all of that variation was wasted variation. It was exploration with no return. But algorithms, the good thing that they can do with data is they can now squeeze a lot of juice out of that exploration. So if we're squeezing more juice out of exploration, clearly the point has moved to that level.
Okay, that's it for our show on unpacking Maneva. Who knew there was so much to learn about the future from old school factories? Thanks to Rich, Niamh, and Sendhil. We'll post links to our social media at intrepidgp.com. Thanks everyone for listening.
The views, opinions, and information expressed in this podcast are those of the hosts and guests and do not necessarily reflect the official policy or position of Intrepid Growth Partners. This content is for informational purposes only and should not be considered as financial, investment, or legal advice.